In this part of the episode, I would like to talk to you about simplifying fractions. This is also sometimes known as reducing fractions or writing fractions in lowest terms. But I like the word simplifying because you hear the word simplifying used a lot in mathematics, not just for fractions, but for lots of other things that you will be dealing with as you finish Math 70 and Math 72. In math, when we talk about simplifying a quantity, we're talking about rewriting it so that it's the same as it was at the start, but it looks a little bit different. Maybe it contains smaller numbers or fewer symbols. Simplifying means it's the same number, it's the same quantity that you started with, but it's a little bit nicer and easier to work with because the numbers are smaller and there are not as many symbols in what you're working with. So we are going to be talking in this part about simplifying fractions, rewriting fractions so that they represent the same amount, but the numbers in the fraction are as small as possible. Now, we know that when we're rewriting fractions, there are only two possible moves, right? There are only two possible ways to rewrite a fraction. Way number one is to multiply the numerator and denominator by the same number. Way number two is to divide the numerator and the denominator by the same number. And since we're trying to simplify the fraction, since we're trying to make it nicer than it was before, we don't want to be multiplying here, right? Because those will just make the numbers larger. If we want to simplify a fraction, our goal is to divide the numerator and the denominator by the same number. That way, the fraction stays the same, but it looks different, and it's a little bit easier to work with because the numbers are smaller than they were before. So when you're simplifying the fraction, that's the process. Step number one is to look for a number that evenly divides both the numerator of your fraction and the denominator of your fraction. Once you have found a number that evenly divides both the numerator and the denominator, your next step is to go ahead and divide that number out. And then the final step is just to repeat this process until you cannot find any numbers that evenly divide both the numerator and denominator. Let me show you what I mean. Someone asks me to simplify 2 and 4. So the first thing that I'm going to do is I'm going to ask myself, can I think of a number that can evenly divide 2 and it can evenly divide 4? Well, I think the number 2 goes into both 4 and 2 evenly. So let me divide both 2 and 4 by 2, and that gives me a new fraction. It's the same amount that I had before, but it looks different. Instead of cutting my pizza into 4 slices and taking 2 of the slices, I'm going to cut my pizza in half and take one of the halves. In the end, I get the same amount of pizza. It's just this one was a little bit simpler and required less cutting. So now I'm going to check. Okay, this was my sort of first pass through the fraction to divide out a 2. Is there anything else, any other number that goes evenly into 1 and 2? Not really, right? 1 is already really small, so you're going to have a hard time dividing that by anything else. Let's have a look at this fraction. Someone says to me, simplify 6 and 15. Is there a number that goes evenly into both 6 and 15? Is there a number that can be divided out of both 6 and 15? There is actually a pretty interesting way to approach this if you have a times table. If you have a times table, if you look through the rows of your times table, you can look for a row that contains both 6 and 15. For example, in our times table here, I can see that both 6 and 15 show up in this row that is labeled 3 on the side. And that means that 3 can go into both 6. 3 goes into 6 two times, and 3 can go into 15 as well. 3 divides 15 5 times. So I think I will try to divide both 6 and 15 by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So the simplified version of this same fraction would be 2 over 5. It's the same amount, it's just the numbers are smaller. Now, can I reduce this any further? Is there a number that evenly divides both 2 and 5? I don't think so. Because, for example, if I look at my times table, the only row in which 2 and 5 both appear is the row that's labeled by 1. And dividing by 1 isn't going to help me to reduce my fraction any further. Dividing by 1 doesn't change your number at all. So 1 doesn't really count, and 2 and 5 do not show up in the same row anywhere else in this table. So I think that 2 over 5 is as simple as this one is going to get. Okay. Now, someone says to me, simplify 8 over 12. Simplify 8 over 12. So I am asking, is there a number that evenly divides 8 and 12? Now, depending on what you notice first, this problem can evolve one of two ways. Some of you may first notice that 8 and 12 are both even numbers, so they can be evenly divided by 2, for example. If I divide both 8 and 12 by 2, then I'll get 4 in the numerator and 6 in the denominator. So I get 4 over 6. But now, looking at this new fraction 4 over 6, I think that these numbers can actually be divided again. 4 and 6 are both even, so 4 and 6, 2 goes into each of those again, and I get 2 in the numerator and 3 in the denominator. Now I think there is no number that goes into both 2 and 3, so I think this is as simple as the fraction will get. Alternatively, looking at this problem, you may have noticed or may have, for example, seen in the times table that 8 and 12 both show up in the row that's labeled 4 on the side. 8 and 12 are both showing up in the row labeled 4. 4 goes into 8 two times, and 4 goes into 12 three times. So if you notice that, you can divide by 4 from the start. And 8 divided by 4 gives you 2, and 12 divided by 4 gives you 3. And that maneuver will get you 2/3 right away. That'll get you to the answer in a single step. Either one of these techniques is absolutely fine. To simplify your fraction, if you divide it by 4 right away, then you only had to do it one time to simplify the fraction as much as possible. If you divided only by 2 in the beginning, then the fraction could still be simplified a little bit more. So we would have to divide by 2 again to make the fraction as simple as possible. One final example. Someone says, I have 21 out of 9. Let's simplify this fraction. To simplify 21 over 9, I can, for example, go to the times table and look for a row that contains both 9 and 21. And I think I see it right here. The row labeled 3 contains both 9 and 21. So 3 goes into 9 3 times, and 3 goes into 21 7 times. So if I divide both the numerator and denominator by 3, I get 7 in the numerator and 3 in the denominator. So 21 over 9 is the same quantity as 7 over 3.